Welcome to Chapter 4 of SDM4. What we see here is really the first time we're looking at a bivariate comparison, the comparison between two groups, which is really kind of at the heart of when statistics starts getting more interesting. One way we can be doing that is by comparing groups with histograms. We'll show how to do this in R. It's not easy to see this because they're not really on top of each other. We do get kind of summary statistics at the bottom of this. But we can start to look at these wind speed data and start to compare whether or not there are differences between groups. It's actually hard to do side-by-side stem and leaf plots in R, but that's something that one might be thinking about. Again, not so feasible with larger groups. What'll be really helpful, even though box plots aren't always as good for showing the shape of distributions, they can be very useful for seeing differences between groups. And that's where really a box plot by itself doesn't really give you much. Here we have the month-by-month box plots, much more interesting. An example here with the roller coasters, the same kind of idea. Really lets us kind of compare distributions in a fairly straightforward way. And here looking at the cups data and to see how things are being brought together, a good example to be looking at. Same as usual, the just checking, very helpful to be thinking about comparisons. Outliers start to become discussed at this point in the book, and we start thinking about different ways of thinking about outliers, whether they're data coding errors or whether they're really interesting things that might potentially win us a Nobel Prize. So we have this idea of the outliers. We take a little bit of a shift in this chapter, and then we have the idea of time plots, where we're thinking about just looking at things over time. And so this idea of a time plot, the x-axis might be the day of the year. And then a really important idea we'll be using a lot throughout the course is the idea of smoothers. Here's the display of the wind speed by time of year, by day of year. We can see it's a really jagged up and down kind of thing. If we actually go ahead and use something called a scatterplot smoother, and that's given here, that line, that can give us a much better sense of the functional form of the relationship between day of year and average wind speed. That's something that you should really take a close look at. Re-expressing data is a way of going ahead and transforming it as a way of providing more symmetry. Typically we'll do this for distributions that have a long right tail that kind of really skewed to the right in that fashion, like CEO salaries, as we see here in exercise section 4.5. And by doing that, we get something on the log scale that looks a lot more normal, something we'll hear about pretty soon. One of the challenges of this, of course, though, is that things are going to be harder to interpret on that scale. And we can do this also to kind of be thinking about equalizing spread. So this merits a close read. As always, things can go wrong, good things, bad things happening to good people, so be careful on those. Think about the learning objectives and the terms for these, and then lots of ways of thinking about things on the computer. So we're going to be doing that in R, and so we're going to be reading things in. Here we read in the Hopkins, the data. We can see the names of that. We can run the histogram function, and I'm setting things up here to match the book with a width of 0.5, centering at 0.24, and that allows us to reproduce the figure. We can do the same thing for the summer wind speeds. We can generate those side-by-side monthly box plots. We see that the variability tends to go down during the summer. So I'm here using BW plot. There's a special thing for BW plot. It needs the grouping variable. So here we have y tilde x. So we want wind speed as a function of month. But because month's numeric, we have to say as dot factor for it. But otherwise, things pretty much the way they were. We can look at the outliers. Let's restrict ourselves just to February wind speeds that are greater than 6. We can actually see from that. Now display that, we can see there's just the one observation that has a wind speed of 6.73 as an average. Do the same thing for the June outlier. XY plot is our function to plot a scatter plot, same general syntax. Y in this case is average wind speed, X is day of year, and we can see that kind of general pattern. However, it's much clearer if we go ahead and add the smoother. The way that we add the smoother is by using the type equals option. We say type equals P, and we say type equals smooth. We glue those together with this function C for concatenate. So by doing this, we get both the dots and the smoother, and we can actually see that representation. So the CEO salaries, as we saw, were dramatically skewed. Here we're going to be using the mutate function to go ahead and create a new variable that was called log10 salary. We'll get more practice using mutate, but it goes ahead and adds a new variable log10 salary, which we can then display, and again, it looks like we saw in the book. Again, chapter 4, starting to think about comparison of groups, bivariate relationships, life starts getting more interesting.